Hello and welcome. This video is going to show you all you need to do to get JASP to run an independent samples t-test. So I'm going to assume that you've already got the data file loaded up into JASP, and so it looks something like what I have here. Goes with all the data running down. Of course, I want to point out how the data set is organized a little bit differently when you're running an independent t-test. You have 2 bits of information for each participant. Each participant has his or her own row. So this first participant is in group 1, and that person's pain score, which is the dependent variable, is 4. And as it says up here, group 1 is the people who get the drug. And then if you scroll down, you can see group 0 people, and those are the people who got the placebo. And so we're giving them this drug, and we're going to see if the drug lowers social pain in this example. So you're going to compare the drug group to the placebo group. Now we could run it like this, and the output would give us the mean, and it would show us all that, but the output would show group 0 and group 1, and then you'd have to remember which group is which. And sometimes it's often helpful to have a better, more descriptive label than 1 and 0. So I'm going to show you how to do that quick. You would just click on this variable right there, and then it'll open this screen up. Don't click over here, but click on the actual word. And then 0 was the placebo group, and 1 was the drug group. And so notice how it changes it. Out of that. And now when you get your output, it'll say drug and placebo there. It'll make it a little easier to interpret the output, so it's probably worth your time doing. Now you're going to click on this and click on independent samples T, of course. The drug group, whether they got the placebo or the drug treatment, obviously goes to the grouping variable. The pain variable is your dependent variable that goes up here. And eventually, then this is where you'd pick to get the one or a one-tailed, which would be one of these two, or a two-tailed test. This is the one we want for this one. And then you're going to want to click on all of the same stuff that we've done for all the t-tests, really. Location of parameter, confidence interval for that mean difference, the effect size, the Cohen's d is the effect size we want, then a confidence interval around that, descriptive statistics, and descriptive plots. And there's one other thing we want to click on when we're doing an independent t. We want to click on this down here where it says equality of variances. If we click on this, it's going to give us the Levene's test. This is a way of actually testing the assumption of homogeneity of variance, or equal variances. So what this is actually doing is it's returning a p-value. This is the Levene's test. It's returning a p-value to test the null hypothesis that these two standard deviations are similar. If this p-value is very, very small, then you have evidence that you might be violating the assumption. Well, if it's very, very small, you are violating the assumption. You have a good reason to believe that you're violating the assumption. This standard deviation is about 2, and this one's about 2.5. So those don't look very different to me, and it doesn't seem like there's really compelling evidence for that. And you look up here, a p of 0.09, it's marginal, but in this situation, I wouldn't say that the assumption is violated. There's not really enough evidence to say that it's violated. So these are close enough to assume that they came from populations with similar standard deviations. So we would go ahead and use the student t-test, which is what is automatically checked. Now, if this were very, very low p-value, then what you would do is not want to use the student t-test, and instead you'd want to use the Welch t-test. Now, the computer will run both of them for you. So I'm going to click it here, and then it'll automatically do both. Now look at what you get here. The t statistic is exactly the same, and that will be the case. Then what's different is the p-value. When these are very different, you will get a different p-value. You'll notice the p-values are almost identical. And that's because these aren't very different. This p-value wasn't that compelling. If this p-value was compelling, then the p-value for the t-tests, these two, the Welch's t-test and the student t-test, these two p-values would be more different. But based on this, I would just go ahead and use the student test. So I'll try to unclick that so we don't accidentally get the wrong numbers when we need them. And then we have everything we need over here. Now for this, I'll walk through that in a second. Now for the second activity 7.2, that's going to be a case where you're going to want to use the Welch's test. And I'll show you that when I show you that video. But here's all the information you need. Here's your independent t. Here's your DF. Notice that it's DF of 60. We must have had 62 participants. Here's our p-value, the mean difference between these two means, the error variance, in other words, the standard error of the mean of the difference, that confidence interval around the mean difference, the d, confidence interval around that d. And again, this is the tricky part for tests. You're going to have to know how to interpret these confidence intervals, this d, this p, but it's really the exact same interpretation you've had for the last two chapters. So hopefully it's starting to get a little easier. And again, the graph is interpreted the same way, descriptive statistics. All of this is the same. So I hope that is enough to help you do just fine on setting up activity 7.1. I'll be reviewing this in class on Tuesday.